Hello friends, welcome back. In today's video, we are going to see complete fire hydrant installation details using a practical project from the Middle East. In this layout, you can see the fire hydrant pipeline in a 3.2 kilometer very long infrastructure project from the Qatar. So if you see the downside of the drawing, for example, at this point, you can see the existing pipelines, I mean this line, the existing pipeline which is passing like this, straight away like this. From here, I have taken one tie-in connection like this, and this tie-in connection point which is going to the pumping station. So this is the underground pumping station. So from this underground pumping station, we have the supply connection. Like this one, you can see the supply connection which is going this side and also which is going this side. So this is supplying to full firefighting system network, and also whatever the point you like see here, this is the fire hydrant which is properly installed with some distance. So we will see all the installation requirement in this video. So like you see here, the first blue color line which I highlight here. So this is the main line, or you can see in this image also. So the main line is passing here. So from the main line, we have taken the branch. In the branch, we have installed one isolation wall. So from the isolation wall, after that, the straight pipe is going here. And here at this point, you can see a bend that is called as a S bend. I will show the same detail in the drawing also for your clear understanding. So from the S bend, we have the duck foot bend. This is called as a duck foot bend. You can see in this image also. This is a duck foot bend. From the duck foot bend above, we have taken the pipeline, and here we have installed in the fire hydrant line. So this is the common installation design. So we will see the detailed one in the drawing itself. And the item which you see here is called as a breakable traffic plank. This is one of the important installation item we have to see when we go for the installation of the fire hydrant. First, when we discuss about the overall system, so I'm starting from the initial part. So here we have the breaching inlet. So breaching inlet, the fire department connection supply the water to the two fire compartments. I mean the fire tank here with the two compartments. So from here we have the supply side. We have the fire pump set. That means one electrical pump, one jacky pump, and one diesel pump. So we have a fire pump set here. So from the fire pump set, this supply line which is connecting to this one, and also here you can see there is one more line which is going as a branch. So this line is going to the sprinkler system and a fire hose reel cabinet. We have the class 1, class 2, class 3. There are different type of systems are there. So which is going to that side, and coming to the other side, like here we have the connection which is going to the fire hydrant. So this is the building located here. So surrounding this building, so completely we have the fire hydrant which is placed with some different distance that we will see now. So after that we have the fire hydrant, the box or fire hose cabinet. So this is for the connection of this one during the fire event. So this is the combined system riser. So actually saying, as per NFPA, we are allowed to use the combined system. It includes the, like you see here, we have the alarm check valve, so which is monitoring the sprinkler system. We have the fire hose cabinet. Also we have the fire hydrant. So all these three systems are supplied by the common firefighting pumps. So it is allowed to use the combined system using the single fire pump set as per NFPA. Coming to the fire hydrant material, so the first important thing we have to see, that is the material, like in the pipelines. So as per NFPA 14, underground fire hydrant pipes can be PE pipe, I mean the polyethylene pipe like a HDPE, this type of polyethylene pipe, then ductile iron pipe, copper pipe also we can use, plastic PVC pipe, then steel pipe also we can use like a carbon steel pipe, then concrete pipe, I mean the reinforced concrete pipe we can use. So coming to the Middle East, in the Middle East mostly for the underground application we are using HDPE underground pipes, and the grade, if it is mostly asked in the interview also. So underground pipe for the firefighting we are using HDPE ISO 4427 SDR 11 or SDR 9 PE 100. So what is SDR 11 or SDR 9? So there is an important thing we have to understand. Based on ISO 4427, HDPE PE 100 pipes SDR rating vary from SDR 7.4, that means 25 bar, to 41, I mean a 4 bar. So coming to the requirement of the standard, like you see here, as per this ISO 4427 standard, you can see the SDR rating SDR 41 until SDR 7.4 is available. SDR 41 means the PN4, that means 4 bar. So the piping system has the pressure rating of 4 bar. till PN25. That means SDR 7.4 mean it is 25 bar. So the concept here is when the SDR number decreases, the pressure rating will be increased. So here how this SDR number is decided. So we have one example. For example, you see here we have the 110 mm dia pipeline. Let's say that the thickness of the pipeline is 6.6 mm. So OD is 110 mm, wall thickness is 6.6 mm. So what is the SDR rating? Outer dia divided by wall thickness, that is 16.6 is which is equal to SDR 17. So if you go up here for this item, you can see SDR 17. So this is how the SDR ratings are decided for the ISO 4427 HTP piping system. But normally we have to understand one more important concept for this one. As for NFPA, the working pressure of the firefighting system is not less than 150 psi. 150 psi means 1 bar is equal to 14.5 psi. So it is around 10.34 bar. So 10.34 bar means if you go to the table, here you can see SDR 11 which is PN10. That means 10 bar. So we need minimum the pipe working pressure is 10.34 bar. So I cannot use any pipe within this range. That means PN4 to PN10 I cannot use. I have to choose go with the higher grade like this way. So normally most of the countries in Middle East we are using PN10 bar. That means SDR 11 piping we are using for the underground firefighting system. But there are some changes here. For example, if you go to UAE and if you follow the UAE fire and life safety code, it is very clearly mentioned that the underground piping shall be HDPE and with a minimum SDR ratio of SDR 9. So it's very clear that the PN rating even they are not accepting PN 16 bar, and if you see here PN SDR 9 means which is here. So that means minimum PN 20 piping, I mean 20 bar piping should be there for the underground firefighting system based on the UAE fire and life safety code, and they are clearly highlighting few more points for you. So steel piping shall not be used for general underground service, but as per NFPA we are allowed to use the steel piping also for the firefighting system, and this point we should note down when we go for the UAE. In addition to this one, they have some special points for the firefighting system. So what they are telling, the water for the hydrant system shall be potable type water, and the TSC or treated sewage effluent water also acceptable. Tested for the firefighting purpose shall be acceptable, and here the lake and pond water shall be acceptable provided that means sufficient water level reserved is ensured at all the time. So always we have to make sure that the sufficient water reserved is there in the when we are using the lake and pond water. So these are the special conditions we have to consider when we go for the UAE fire and life safety code. Hello friends, 1 minute. We work hard to collect all the information from various sources to give you best understanding of the subject. Most of the people watch the video but they don't subscribe. Please motivate us by subscribing our channel to post more and more technical videos for you. Thank you. So coming back to the next important point, breakable traffic flange. So this point I told you, during a collision with a fire, the first component to fracture is the breakable traffic flange. So here you see this is the breakable traffic flange. So as per the and normally it is designed to fracture when a 6,000 pound force is applied to side of the hydrant. So during the accident the force will be more than that one, and if it is more than that one, surely the first component which is broken here is a breakable flange. And coming to the second important point, I mean the installation point, it is required to install the flange 2-inch minimum to 8-inch maximum distance from the finish level. So normally if you consider this is the finish level of the road or the paved area, paved block, whatever it is, from here minimum 2-inch should be there and maximum 8-inch should be there. So this point we must follow when we go for the installation. Similar to the piping, we have to consider some additional requirement in the fire hydrant installation. So it is not allowed to install below valve in the fire hydrant line. The first one is check valve or non-return valve. So like you see in this image, we are not allowed to use any check valve or means non-return valve in this line. So we must use only the isolation valve because of the maintenance purpose. If you want to do any maintenance in the fire hydrant, we can use the isolation valve for the isolation, and we are not allowed to use the backflow preventer valve also in the firefighting system. And as I mentioned here, gate valve we have to use for the installation means the maintenance purpose of the fire hydrant. The minimum depth of cover shall be 0.8 meter to prevent the mechanical damage. So from the finish level to the top of the pipeline, minimum 0.8 meter we have to follow here. So like you see in this example, I have shown different technical term related to the levels. For example, this is the pipe, what you see here, and the inside portion of the pipe, it is called as a invert level. So invert level means from the sea level, somewhere sea level, we will measure the invert level till this point. So this is called as a invert level. Normally most of the people consider invert level means the outer side of the pipeline. Is not correct. We have to measure only the invert level, means the inside of the pipelines to the sea level. So this is normally given to your project by the surveyor. So the top of the pipe here, and this is the finish level. So finish level to this one we called as a this is the depth to top of the pipeline. And similar to the invert, we have one more option that is called as a upward. So upward means like this point. So this point, and here we can someone calls a crown level also. So here, so the first requirement is this distance must be minimum 0.8 meter for all the installation, but there are some limitations also there. We will see that one. So like we see here, this is a general condition that minimum depth of cover shall be 0.8 meter to prevent mechanical damage, but this can be increased to 0.9 meter if the pipes are passing under driveway. I mean, if there is any road is there, the pipe is passing under the road, then this depth will be increased to 0.9 meter. And we have other special requirement also. Pipes under railroad track shall be minimum 1.2 meter depth, so slightly higher depth it has to go. So minimum of 6-inch pipe shall be used to limit pressure loss and permit greater flow capacity. That means the branch pipeline should be minimum 6-inch to permit to limit the pressure loss and also to permit higher greater flow capacity of the fire hydrant. Coming back to the drawing, you can see the fire pumping station. So from fire pumping station, the line is coming out and it's going like this, and also one more branch is going this side also. So this is the upside. I will show in the another part of the drawing. So first, if going down, we have the isolation wall located here. So from the isolation wall, you can see this is the main line which is passing like this. From the main line, we have taken one branch line for the fire hydrant at a different distance. So this line is going all the way till this level. You can see here. Moving further, so till this is the 621 means 621 meter length of the pipeline. So similar to this level, this is the upside of the portion. For example, the first drawing we show the downside, which was going like this, and this is the upside of the portion. Again, we have to provide the isolation wall at the all T at all junction. We have to provide the isolation wall. So this again, this line is going till here. So continuation of this line we can see in the next part also. So like you see here, from this line again this is continuing here. So this line is going like this. You can see the length we have mentioned one by one. So this is 1 plus 000 mean 1 kilometer, almost 1 kilometer length from the pumping station. So which is moving further like this. So the next part of the drawing you can see. So this is continuously, this line will go and till the last 3.2 kilometer distance, this will go in this way also. So coming to the isolation wall, because like you see in the drawing, we are providing the isolation wall here. For example, in the main line we are providing the isolation wall. This isolation wall is normally a buried line, so we have to know some important detail about the isolation wall installation. So first, coming to the pipeline system, so this is the DN means the nominal dia. So this is the pipeline dia, and from here in this project, if you note down the pipe material what I used for this project, that is a ductile iron material, 200 dia. As per NFPA, it is allowed to use the ductile iron also. So 200 dia ductile iron pipe material I have used for this project. So coming back to the valve installation, so first pipeline. So this pipeline for the ductile iron is a socket and spigot type arrangement that I will show you later. So from here the line supply flow. So first arrangement is a flange adapter here. So flange adapter we have installed here, and after that we have the buried wall. This all system is the buried one. So because you see this is the finished level, this is the finished level, I mean the finished ground level. So this full system is the buried line, and we have the isolation wall here. From the isolation wall, the top of the isolation wall, you can see here 150 PVC tube I have provided here. So because if I want to do any maintenance, I can open this cover, because this is a heavy duty 150 by 150 ductile iron surface box. I can open the surface box. I can access from the top side finish level. I can use the key. So key I can put inside. So from the key I can open and close the isolation wall. So this option normally we are installing. So after this one, this pipeline is going straight away like this, and here we will provide the puddle flange. Like you see here, we have provided the puddle flange, and bottom of the isolation wall we have to provide the concrete support. So all this setup will come inside the isolation wall chamber. So this is the buried one. This is completely buried one. You can see it's a selected granular material. That means this option is a buried one. From the top side we can access the isolation wall for the on and off purpose. In this network, wherever we have the T elbow like a 45-degree elbow, 25, 22.5, 90-degree, wherever it is, we have to provide the thrust block arrangement like this. So coming to the thrust block, this is one example for the 90-degree bend. So we have different pipe sizes given from 100 mm to 300 mm. So coming back to the sizes, the A means the concrete for this thrust block. We have to provide the A. For example, for if you consider the 200 mm dia, I have to provide 700 mm concrete at this point A. And coming back to the B, at this level, we have to provide around 1250 mm thrust block arrangement. Then C and D, you can see here the C here. So here we have to provide the concrete, and also D, which is overall dimension from here to here. This is the section drawing. So this is the key plan, and if you take the section at this section level, if you cut at this level, so we can see the image like this. So this is the nominal dia of the pipeline, and we have to provide the concrete in this way, and we have to make sure that from the finish level 1500 mm minimum we are keeping for this arrangement. So similar to 90-degree, I have shown here for the 45-degree also. The dimension only will vary based on the different pipe sizes. It will vary, and you have to follow this one for the thrust block purpose. So this is one of the very important drawing related to the fire hydrant system installation. So this is the main pipe. So in our project it was 200 mm dia. From the 200 mm dia, we are making the branch with 150 mm dia. So as I told earlier in the isolation valve installation, this is the flange adapter, and we have the isolation valve here. We have the PVC tube and 150 mm PVC tube, and this is the surface box we can access from the top side. After that we have the straight pipe, and here we have one special arrangement called as a S bend, because normally the pipeline, which is the main pipeline, this level will be different, like 1.5 meter, 1.2 meter, different level. So when we come to the branch pipe installation, we have to keep the fire hydrant at higher levels, this one. So that is the reason we want to adjust the level. So to adjust the level, normally we have one special fitting called as a S bend. So this one can adjust the level. So because here we have different level, here we have different level we have to provide. After that we have the concrete support. This is called as a duck foot bend with the concrete support we have to provide. And after that we have the hydrant standpipe lower part. So this is the breakable traffic plan. As I told, 2 inch to 8 inch the distance we have to provide for this. So after that we have the 4 important protection post. So some people will call as a bollard also. So four steel posts with 100 mm dia surrounding the hydrant. And here normally what we are doing, we are providing the we are filling the concrete inside the steel post for the extra strength purpose. So like this one, you can see the top view. So here I given the material of construction, different material which is used for this one. The H1, as I shown here, it is a fire hydrant, and H2 is the duck foot bend, which is the bottom arrangement. I showed in the section view. And flange spigot, that means the H3 means this is the pipe, straight pipe with a flange spigot pipe, and H4 is the gate wall with this item, and H5 is the T arrangement, because here we have the main pipe. From here we have to provide the T. So H5, and H6 is the regulating S bend. So at this level it will come. I showed the arrangement was like a S bend like this. So to manage the different levels, and if you see the production post, this production post will extend below the ground level. So this one you can see we need to provide 800 mm depth here. So 150 mm it will be filled with lower level, below it will be there, and 300 mm concrete will be there. So here 50 mm projection will be there for the concrete, and from the bottom level 900 mm minimum we have to provide. So after that we have two arrangement. If the free space is more than 900 mm and the space is less than 900 mm, because normally what happen, if you see the layout drawing, we have to see one important item here. So here we have shown the layout fire hydrant. So from the main pipe we have to take the branch. In this branch, sometime we have the road, sometime we have the paved block, sometime the landscape area, different arrangement will come here. So we have to make sure that what is the space available in the site for the fire hydrant branch installation. If you have more than 900 mm, we can make the branches straight arrangement, straight installation like this we can make. If you have less spaces, 900 mm and less, then we have to take the branches, we have to take the bend like this. Here we provide the installation like isolation wall and the fire hydrant we have to provide based on the free space available in the site. There is one important thing we have to understand related to the clearance for the fire hydrant. So as per the code, for example, NFPA 1 fire code require the following clearance around the fire hydrant. So if you see the first requirement, if you have the fire hydrant here, so minimum 3 feet, I mean the 36 inch or 914 clear space shall be maintained around the circumference of the fire hydrant except as otherwise required or approved. And additionally, if you have to provide in the front side of the fire hydrant minimum 60 inch or 1524 distance has to be provided if the connection size is more than 2.5 inch So this is the new requirement in the code, because earlier it was not there. Let's say mentioned here 18.5.72 is a new requirement as per the code. And because normally what happens, sometime when we are going to connect with a fire engine bumper connection, it makes the obstructions. That's the reason this new code implemented in the code. So coming to the next important installation requirement of the fire hydrant, we have to make sure that the fire hydrant installation is done in the way that the center of the hose outlet shall not be less than 18 inch or 457 above the finished grade level. So for this is the finished grade level. From here we have to make sure that the center of the hose outlet is minimum 18 inch and maximum 36 inch. This hydrant shall be set on the flat stone or concrete slab as a base of the hydrant installation, and it shall be provided with the small stones around the drain to ensure drainage. For example, if you see in this image, we have the drain holes in the bottom of the fire hydrant. So in order to make sure the proper drainage of the water, so we have to provide the small stones surrounding the fire hydrant instead of simply installing the sand for the proper drain purpose. The next one, coming to the fire hydrant testing. So if you see the NFA requirement, normally working pressure of the system is not less than 150 psi or 10.34 bar. So when we go for the testing pressure is minimum 200 psi or 50 psi excess of system working pressure. Let's say we have one example where we have the system working pressure is 170 psi. So this is less than 200 psi. So what we have to make sure that the minimum testing pressure is 170 plus 50 psi. So total the testing pressure must be 220 psi, and it should be maintained for 2 hours, and maximum leakage rate of plus or minus 5 psi is acceptable for the fire hydrant installation, fire hydrant testing. So like I showed you earlier in the starting of the video, we have provided the we have different services in the underground system. Like you see the electrical services are passing above higher levels. So the bottom one is the here you can see the blue color line is the main line, which is 200 dia, and from here we have provided the isolation wall. So after that we will provide the isolation wall chamber also, which is not yet provided here. So it will be coming the later one. So after that we have the branch pipeline, and here we have provided the S bend because of different levels from the main line and the branch line. So we have the duct foot bend, and here the fire hydrant pipe is there. So this is the breakable flange, and finally we have the fire hydrant. So thank you for watching the video. In the coming videos we will discuss about the fire hydrant design also, how to make the pipe, how to make the piping size, so what are the flow requirement we have as per NFA and as per the Middle East different code requirement like UAE fire safety code, Qatar civil defense and all. So we'll see that one in the coming video. So thank you for watching the video. We'll see you again with another interesting video.